Okay, we are starting lesson 74 and we are simplifying square roots today. Your objective is to simplify square roots, also called radicals. Okay, now when we simplify square roots, we have to make sure that we don't have perfect squares, okay, that are underneath my square root sign. So perfect squares, here's a bunch of examples. Those are just numbers that I know the square root of, okay, that have integer square roots, meaning positive or negative numbers. So, for example, the square root of 0, well, that is just 0, because 0 times 0 gives me 0. The square root of 1 is positive and negative 1, because positive 1 times positive 1 equals 1, and negative 1 times negative 1 equals 1. Square root of 4 is plus or minus 2, positive and negative 2. Square root of 9, plus and minus 3. And the square root of 16 is plus and minus 4. Now notice these are all integers, okay, meaning positive or negative whole numbers. So these numbers underneath the square roots are perfect squares because their square roots are integer numbers. Okay, and we can keep going with this. I'm going to give you a bunch of these perfect squares, and a bunch of them we should know already. Square root of 25 is plus and minus 5. Square root of 36 plus and minus 6. And we can see the pattern here. Square root of 49 plus and minus 7. Square root of 84 is positive and negative 8. Square root of 81 is positive and negative 9. Square root of 100, positive and negative 10. Square root of 121 is positive and negative 11, because 11 times 11 gives me 121, and negative 11 times negative 11 gives me 121. Square root of 144, positive and negative 12, and positive and negative 13 for 169. I'm going to go ahead and move this over a little bit. Square root of 196 is positive and negative 14, and the square root of 225 is positive and negative 15. Okay, all these perfect square numbers, 0, 1, 4, 9, 16, are good for us to know, okay, to know their square roots. Non-perfect squares, on the other hand, are numbers that don't have integer square roots. So for example, if I take the square root of 31 and put it into the calculator, I get 5.567764 ... That number keeps going and going and never repeats, so that's an irrational number, square root. Okay, and the square root of 28, for example, is not a perfect square because I get 5.29150 ... and it just keeps going and going and going. Okay, so again, perfect squares are numbers that we know the square root of. Okay, these could be decimals in here too, like if I had 0.25, okay, the square root of that is 0.5, but for the most part we're going to be dealing with these whole numbers and perfect squares. Okay, now let's go ahead and get started on simplifying some square roots. So we need to know this. A square root is all the way simplified if, number one, it has no perfect square factors. So for example, I know what the square root of 4 is because 4 is a perfect square, and I know that that is positive and negative 2. Okay, because 2 times itself gives me 4, and negative 2 times itself gives me 4. So this square root is not simplified. I can break that down yet, break it apart. Okay? If there's no fraction underneath, or it has to have no fraction underneath the square root sign. So if I get a square root that's got a fraction underneath it, we'll learn this at some point in time later. Okay, but what I do is I break this apart into the square root of 3 over the square root of 9. Okay, so I just took the square root sign and put it on the top and the bottom. And I can simplify this. Okay, well the square root of 3, that's not a perfect square. I don't know what that is, so I'm going to leave it alone. Okay, but I do know the square root of 9, that's positive 3. Okay, so this is a simplified radical, or square root, because again, I cannot break this down any farther. I don't want a decimal answer. Okay? And number 3 is we can have no square root in the denominator. So for example, this right here, I can simplify that yet. So the top stays as 3, and the bottom, the square root of 4, is 2. So that's simplified now, 3 over 2. So again, a square root is always simplified if there's no perfect square factors, okay, meaning there's no number times itself, or there's no number that's a factor of this that I can break apart. Okay, and we'll look at some examples, different examples like this one. Again, these are good to know, but we won't talk too much about those right now. So let's keep moving on. Now here's the product property of square roots. It's saying if I have a square root where something is multiplied by something else, then I can break it apart, okay, and put the square root of the first factor times the square root of the second factor. So for example, if I write something like this, the square root of, let's do 4 times 9. Okay, well that's the same as saying I can take the square root of 4 times the square root of 9, which is equal to the square root of 4 is 2 times the square root of 9 is 3, so that equals 6. Okay, so again, if we got factors underneath here, I can break them apart. And then if they are perfect squares, then I can find their square roots. Okay, let's do another example. The square root of, let's say, 4 times 7. That equals the square root of 4 times the square root of 7. Well, I know the square root of 4, that's 2. I don't know the square root of 7, so I'm just going to say this is 2 times the square root of 7, because I don't know what this one is. Okay, and it can't be broken down anymore. It's got no numbers in here that are perfect squares. Okay, now same way, we can do something that looks like this. If I can have the square root of 3 times the square root of 11, okay, I can combine those into one radical, into one square root, and I can say that's the same as the square root of 3 times 11. So basically what I did is I took this and reversed it. I started with these and made it look like this. And then I can just rewrite that. That's the square root of 33. Okay? So this is the product property of square roots, meaning I can take factors and break them apart, okay, with the square roots. So let's look at how this is going to help us now simplify radicals. Okay, now it says to simplify the square root of 216. That does not mean take 216, plug it into your calculator, and tell me the square root is about 4.7 or 14.7. Okay, I do not want an approximate answer. I want an exact answer. So we're going to simplify this by using the product rule. Okay, meaning I want to take the square root of 216 and see if I can find some factors of 216 that are perfect squares, okay, to break it apart. So I'm going to start by making a list of factors of 216, which means numbers that multiply together to make 216. So for example, 1 times 216. Well, 1 is a perfect square, but that doesn't do me a lot of good, okay? And 216 is not a perfect square. We just said that's about 14.7, okay? I don't know exactly what times itself equals 216. So let's try some other factors. I know 2 times 108 gives me 216. Well, 108 is a number that I don't know the perfect square of. Okay, remember that big long list of perfect squares that I gave you at the beginning of the slide? Or at the beginning of the video? That will help you a lot to figure out what are some numbers that might go into 216. So I would look at those and see, okay, what numbers do go into 216. So let's see, 3 goes into 216, and we want to figure out how many times it does. And 3 times 72 gives me 216. Well, neither one of these were one of my perfect square numbers I had at the beginning. So how about 4? 4 would be good because 4 is a perfect square. Times 54. Okay. Well, I found a perfect square number, so I could break this apart using this, but I want to try to find a higher perfect square number. I want the highest perfect square number that I know will go into 216. So I'm going to try some others yet. Okay, well I know 5 doesn't go in because 216 doesn't end in 5, so let's try 6. Well, 6 times 36 is 216. So here I've got another perfect square number, and this one's a lot higher than 4. Okay, so this is better. I'm going to take this, and I'm going to break the square root of 216 into the square root of 36 times 6. Okay, because now I've got a perfect square factor right here. So now I can say the square root of 36 times 6, which was the same as the square root of 216, is equal to the square root of 36 times the square root of 6. Okay, let me go ahead and write factors of 216 up here so I remember what I was doing. Well, now I know that I can break this apart and say the square root of 36, that's 6. And the square root of 6, I don't know what that is. So this is 6 times the square root of 6. Well, now I've got to look at this radical here and ask myself, are there any more perfect square factors that go in here? Well, the only way I can break 6 apart, besides 1 times itself, is 2 times 3. 2 is not a perfect square factor, because I don't know what times itself gives me 2. And 3 is not either. So I'm done. This radical is simplified. And that is the most exact answer that I could give. Again, no decimal answer. Okay, this is the exact square root of 216. It is 6 times the square root of 6. Okay? Now if you are really good with factors and how numbers multiply together, this method is great. Okay? If you're not, then I'm going to give you another method, and we're going to solve this exact same problem a different way. And this next method is probably the one I'll recommend for most of you. Okay? So let's go ahead and take a look.